Hi, welcome to the part three of quantitative modeling. So it's from Wharton Business School, and I'm just reading out the text transcript. I'm now going to talk about some of the key aspects in the modeling process. So every model is different, but they share some common features in the way that a model was created. So I'll call that the workflow. So typically we begin in modeling process by identifying and defining some inputs and outputs. What does the model trying to predict? What is the key outcome or the underlying variables that are going to help us predict or understand that outcome? So an identification of the inputs and outputs of the model, they need to be articulated, ideally defined. There's also a part where you need to think about the scope of the model. And so when I talk about the scope of the model, it's like what is it being applied to? And so going back to the diamonds example, if we have a look at the size of the diamonds that a model was trying to predict, it was little diamonds, basically between zero point 0.1 and zero point 0.3 of a carat, and that's what I mean by the scope. It was a model was being created to work in a particular instance. I would not sit here on and sit here and I claim that the same model would be useful for pricing diamonds that weight 1 carat or 2 carats. So you need to think and define what the scope of the model, where is it going to be applied. So those are the inputs and outputs and the scope of the model. Then once you have got some basic building block defined, you're going to formulate the model, and that's very much an art as well as a science. It's going to be a step that involves your understanding of the underlying business process, and it's where all those mathematical and statistical ideas come in through the model formulation. So if you have created a model, then once you have created the model, you should not just go and use it. You need to think about whether or not that model is performing well. In particular, two of the activities that we typically go through once we have created a model are sensitivity analysis. So all of the models take inputs, the underlying assumption, how sensitive are the outputs to those inputs, and identifying where those sensitivities lie help us understand the value of the model, and where in particular we might be reticent in using it as there's sensitivity analysis. There's also what I would term as validation of the model forecast. So sometimes the models are going to be used in some forecasting or prediction context, and it would be foolish to use a model that was creating forecasts without at some point looking to see whether or not those forecasts were close to actual values that ultimately were observed. And so sometimes that's sort of easy to do. When there's an election, you can look at a political poll that will try and tell you who's going to win the election. Then the bans happens. Election happens, and you actually get a point that you can validate the initial polls again. So oftentimes there is an ultimate realization. So for example, maybe we have a model for the price of oil in 1 year's time. So I'll make my forecast. Then what I should do is in 1 year look to see what the price of oil actually is and see how close my forecast is to the actual price. Now validation takes many forms. That's sort of what I've discussed was looking out into the future. Maybe your data doesn't come over time. Your model isn't a time series model. Then what one often does is withhold some of the data from the model itself, and all we call that a holdout sample. Then that we might do is fit the model, train and model on a subset of the data that we have available, and look to see how well it forecasts in the holdout sample. So there should typically be some validation process after the model has been created. Then if you are happy with the validation and sensitivity analysis, you ask the big question, and the big question is not in the model, right? Because as I've had say, almost every model you create is going to be a simplification, so it's not going to be perfect. That's an unrealistic assumption, and that's why I have put in here, is the model fit for the purpose? And so that is a question that the person creating the model has to decide. Is it suitable for the purpose that it's being used for? Not is it right, but is it helpful? And there's a very uh, famous saying by Professor Code Box, who said all models are wrong, but some are useful, and that the idea that I'm trying to get at when I say is the model fit for purpose rather than is the model right. Now, if it's not fit for purpose, if you're not happy with your model, then you're going to go back and revisit some of the initial steps. Maybe you need some additional inputs. Maybe you have been using your model out of scope, and so you need to redefine your scope. Certainly you might need to reformulate the model as you realize, as I say, for example, that an important variable had been missed out of the model, and so it is an inherently iterative process, this model building. In my own experience, I have never managed to write down a model and use it the first time around. That there's always this feedback component there, so you shouldn't feel that that is a failure in any sense. It is absolutely to be expected, but at some point hopefully you declare your model fit for purpose, and you go into the ultimate activity, which is to implement it, and that's the part that takes you to the spreadsheet modeling component of the specialization. So those are the key steps in the modeling process. Now, as I have alluded to, there is an iterative component to this. So what happens if the model doesn't work? What happens if some of our forecasts are lousy? Is at the end of the world? Well, I don't think so. In fact, when the observed outcome from the model differs greatly from the model's prediction, so it was a lousy predicting model, hopefully not everywhere, but maybe 1 or 2 points of observation, then it turns out that that can be very, very informative because if you can identify the reason why your model has not predicted or performed well, you have probably learned something new that you didn't know before, and that is one of the great benefits of modeling, the actual ability to learn new things. Through the process of realizing that your current understanding is unable to map to reality. And I have got an example in a couple of the modules coming up that will make that point more explicit, and I would certainly come back to it. So the story is not to be totally disappointed, or if the model isn't always working, there's an opportunity to learn something new there. It is definitely the case. The modeling is continuous. It's an evolutionary process, and ultimately as we do identify the weakness and limitation and iterate through the modeling process, we hope to be able to overcome some of those limitations. So initial model not working well is not the end of the world. It's a chance to learn. That's how I think about it. So thanks for watching, guys, and we'll see you in the next video. Bye.